Hey guys, today we're going to do some projectile motion problems. So basically what you'll be given some type of initial height and some type of initial velocity. So to do these questions, we first have to start out with an equation. Here's what the problems will ask you. Part A says, model the motion with an equation. So the equation you're going to use, and this is number 2 on the sheet that you'll see uploaded. A ball or a rock has been launched from a height of 96 feet at 32 feet per second. So to do part A, the equation that you always use is S of t equals negative 16t squared plus v sub I times t plus s sub I. So v sub I is the initial velocity. So that is 96. This is being launched actually downward. S sub I is the initial height. And that is 96. Now if it says it's being launched from the ground, S sub I is 0. So all you do is you fill in the numbers. Be very careful. V sub I is negative if it's downward. If it says it's being launched upward, V sub I would be positive. So this is negative 32. T plus the initial height is 96. So that equation is going to be used for most of the problem. Part B says, when does the object land? Landing means that S of t is 0. So S of t, by the way, is the height of the object, and t is the time. So we're simply going to replace S of t with a 0. And we're going to solve this equation. So you can factor this, or you can use the quadratic formula. I'm going to factor a negative 16 out to make it a little bit easier. And then this remaining trinomial, I could use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. So b is 2. 2 squared minus 4 times 1 times negative 6, and a is 1. So we just keep working through this. The number under the radical is 4 plus 24 over 2, and so there's two answers. Negative 2 plus radical 28 over 2, and negative 2 minus radical 28 over 2. Now if you type this one in, you're going to get a negative, so we're going to reject that. You can't have a negative time. But if you type the other one in, negative 2 plus the square root of 28, and then divide by 2, you get approximately 1.65 seconds it takes for the rock to land. So again, all I did was I replaced S of t in our original equation with 0, and I factored or used the quadratic formula if it's not factorable. Again, remember, S of I is the initial height, 0 if it's the ground. V sub I is the initial velocity, and it's negative if it's being launched downward. Part C asks, what is the object's maximal height? Now, because this one is pretty easy because it's being launched downward from an initial height of 96. So it'll never get any higher than 96. But there are some times it's being launched upward. You would have to use t equals negative b over 2a and plug this number into the equation. So watch what happens if I try that on this one. If I have b is negative 32. Again, I'm getting it from here. And a is negative 16. this comes out to be 32 over negative 32, which is a negative time, which doesn't make sense because the object is falling the entire time. Now, if the object was going upward, you would get a time here. You'd get a positive number. Then to find the height, you just plug it into the original equation. Part D is asking for the velocity at 2 seconds. To do that, you simply take your 2 seconds and try to think of times. Well, let's talk about this. Velocity is change in height over change in time. To find a change in height, this is like the slope formula. You find the height at some future time, and you subtract from it the height at some old original time, and then you divide by the 2 times subtracted. So it's as simple as this. Take 2 seconds and find times, or think of times equally spaced from 2 seconds. What about 1 second after 2 seconds would be 3, and 1 second before 2 seconds would be 1. It's the slope formula. Now to do this, we're going to plug, S of 3 means to plug 3 into the original equation. So what I would do if I were you, I would just simply type it into the y equals negative 16x squared minus 32x plus 96, and then look up these answers. 3 seconds is negative 144, and 1 second is 48. 3 minus 1 is 2. Negative 144 minus 48 is negative 192. Divided by 2 is negative 96 feet per second. So at 2 seconds, the object is traveling negative 96 feet per second. The reason it's negative is because it's going downward. And then the final question is asking you in part B to find the equation of the tangent line. Y minus y1 equals m times x minus x1 is point slope form. M is the velocity, x1 is the time, and y1 is the height at x1 seconds. So x1 is given to you in the problem. It's right here, 2 seconds. So this is y minus 2. M is the velocity. Now since they're asking about 2 seconds, we found the velocity in the previous part to be negative 96. Whoops, I put this in the wrong spot. This is x1, the time. And then all you do to find the height is, once again, you look that up on the table. It says here the height is negative 32 feet. And then you simplify. Subtracting a negative is like adding. Distribute your negative 96. Subtract 32 from both sides. And you get negative 96x plus 160. So one last thing I want to make sure is clear. If you have an object that's being launched upward, to find this maximum height, again, this was part C, you first find the time that it takes to achieve that maximum height using the axis of symmetry equation, and then you plug that number into the formula. So give it a try, have a good day, and let me know if you have any questions.